In this video, we will review circles. So I want to begin by thinking about where a circle's equation comes from. And the idea is to really break down the definition of what a circle is. So let's start with that. A circle consists of all points x, y in a plane whose distance from a certain point, which I'll call x naught, y naught, is r. Okay, so in this context, x naught, y naught, that is called the center of the circle, and r is called the radius of the circle. So this is the definition of what a circle is. Now let's take this definition and let's translate it to a mathematical statement. So looking at this sentence here, the verb in this, the verb is the word is. So when I have a mathematical statement being expressed through a word problem like this, I want to identify the verb, which is, and translate that to a symbol. So is means two things are the same. Something is something. So that stands for an equal sign. And on one side of that, we have the radius. It's saying r is something, or r equals something. So I'll write an r on the right. And on the other side of the word is a distance. So it's the distance from the point xy to the center point x naught, y naught. Okay, now we can use the distance formula to write down the distance between these 2 points. So it's going to be x minus x naught squared plus y minus y naught squared in a big square root. So that's the distance. And that equals r. And if we square both sides, we can get rid of that square root. And that gives us x minus x naught squared plus y minus y naught squared equals r squared. And that now looks like the equation of a circle that we're used to. So this form in which we've put the equation of a circle, I'm going to refer to this as radius center form. So this is the radius center form for the equation of a circle. But often we'll see the equation of a circle written in an equivalent way, which we get by expanding all of this. So expanding gives us something of the form. If we expand this, so if we do x minus x naught times itself and y minus y naught times itself, we'll get something that looks like x squared plus ax. So the a here could be positive or negative. And then we'll have a y squared plus by, and b could be positive or negative, and equals c. Okay, so in this equation, the a, the b, and the c are just some real numbers. So when we have something like this, I'm going to box this one as well. This is also the equation of a circle written in what's called standard form. Okay, and out of the two forms, the one that gives us more information about the circle is radius center form. Because once it's in radius center form, I can quickly see, oh, what the center of the circle is, it's x naught, y naught, and what the radius is. It's the square root of this r squared number that's on the right-hand side. So let's do an example where we have an equation of a circle written in standard form, and let's find the center and the radius of this. All right. So this is a review problem from algebra. So it may have been a while since we've done something like this. So let's review how we do this. So to put this equation into that radius center form, we need to complete the square. Complete the square. Okay. And in fact, I'm going to need to complete the square twice. Once with the x terms, once with the y terms. So we are actually going to have to do it twice. All right, so to complete the square, what we begin by doing is we divide the coefficient of the x term, and in this case there's also y, so the coefficient of y by 2. And that's going to be our first step. So if we do that, the coefficient of x is the 6. So we'll take the 6, we'll divide it by 2, and that gives us 3. Let's do the same thing with the coefficient of y, which is -7. We'll divide that by 2, and that's just -7/2. Let's leave it as a fraction. Then we square those numbers. We square that. All right, so let's take the 3 and let's square it. So 3 and then square that, which gives me 9. And then if we square -7/2, we get 81/4. Oh, oops, sorry, not 81. We get 49. 49/4. So the next step of completing the square is, now we take these numbers and we add it to both sides. Add it to both sides. Let me zoom out a little bit so I can see this whole thing a bit better. So we add that to both sides. All right, so I'm going to take my equation, the equation of the circle. So we have x squared plus 6x. I'm going to leave a little bit of space. Plus y squared minus 7y, leave a little bit of space, and equals 2. So one of the numbers that we got by doing these first two steps was we got 9. So I'm going to add 9, and I'm putting it right after the x terms because I got the 9 from the coefficient of x. But whatever I do to one side of an equation, I have to do it to the other side. So if I add 9 to the left, I got to add 9 to the right. And the other number that we got by dividing by 2 and squaring it was 49/4. And that I'm going to put after the y terms because I got it from the coefficient of y, from that -7. So if I add it to the left, I have to add it to the right. So I put plus 49/4. And now there's one more step. So the last step is we factor the x terms and the y terms separately. Separate, zoom it out a little bit, separately. So what do I mean by the x terms and the y terms? So I want to take the x terms, including this 9 that I've now added, and take the y terms, including that 49/4 that we've added, and factor them. Okay, so when we do this, if we've done this correctly, each of those things that factored should just factor as something squared, exactly. And that's the whole point of completing the square, to make it into a perfect square. So x squared plus 6x plus 9, that's not too bad. That's just x plus 3. And one thing to notice about this, x plus 3 squared, is notice that this number that's in the parentheses when I factor it is the same thing as what we got when we took that coefficient, the 6, and we divided it by 2. That will always be the case if we do this correctly. So we can use that to help us factor the stuff with the y, because that has fractions. So we're going to get y, and then when we divided the coefficient of y by 2, we get, whoops, let's put this in a different color, we got -7/2. So we are going to have to put -7/2 here in the parentheses. So -7/2. All right. And on the right-hand side, 2 plus 9 plus 49/4. If I work this out, so I get 11 plus 49/4, that'll end up being 93/4. Okay, so we got our equation in this radius center form now. So we can write down our center. So the center is these two numbers that I've highlighted, but I switched the sign. So instead of the x-coordinate being 3, it's -3. And the y-coordinate, instead of being -7/2, it's +7/2. The way I sort of remember my little trick is, I think about what do I plug in for the x to make this parentheses term 0, and that's -3. And what do I plug in for the y to make the thing in this parentheses become 0, and that's +7/2. So that's my center. And then the radius is going to be the square root of 93/4, which we can simplify a little bit. We get root 93 on top, and we get 2 on the bottom. So we have our center, and we have our radius. In terms of our goals for this section, we have now done our first goal. We've reviewed where the equation of a circle comes from, and done an example where we find the center and the radius of a circle. In the next video, we will review parabolas and talk about where they come from, where the equation of a parabola comes from.